Hey everybody, and welcome to the next video. So in this video we're going to be following up from the previous one about VPNs, but we're going to be talking a little bit deeper on the components on how it's built. So the first main top level component is something called IPsec. Now IPsec is short for Internet Protocol Security. This protocol is used to provide data confidentiality, integrity, and authentication between endpoint peers in a tunnel. So whether that's, 1 to 1, 1 to 5, 5 to 5, 10 to 10, doesn't matter. Now, this high-level protocol consists of two internal ones. Now, the first one's called authentication header, or AH, and then the other one is encapsulating security payload, or ESP. Now, ESP is what you're going to find in most cases when you're interfacing with a VPN at an enterprise level. However, AH does have its places. So the high-level process here goes as follows. So the first part of the tunnel is we have interesting traffic. So this interesting traffic initializes the negotiation, which is the phases 1 and 2, before it's able to transfer the data. Now tunnels don't always stay up 100%. They have a heartbeat or a ping time that you can keep them alive, also known as a keep alive. You can keep them up all the time. However, by default, you're not going to have that. So you can have it drop the tunnel, and when interesting traffic comes through, it will rebuild and instantiate the tunnel. Now, what is interesting traffic? When you have one host trying to reach something on the other side of a tunnel, the end IP, the target IP that you're trying to touch or send traffic to, is when it reaches the firewall or the router that holds the tunnel, will know that that endpoint is not in the local network, but it is indeed on the other end of this tunnel. Because it's matching to the other end of this tunnel, it is now considered interesting traffic. So once phases 1 and 2, which is more the negotiation start, we'll have entire videos on each phase. It's important to understand what happens in each one of these phases when troubleshooting tunnels or trying to put them up yourself, but we're not going to touch exactly what these are in this video. So once the phases and all negotiation, all the keys are done, everything's been set up, everything's secure, we now have data transfer, which is our normal state of the tunnel. Traffic passes back and forth. Then we have termination, which is what I spoke about either. We either have a keep alive or we don't. If the tunnel goes down, the tunnel goes down. Interesting traffic will rebuild the tunnel and bring it back up. Now, if there's a keep alive, the tunnel will just send a ping from our gateway, which has the tunnel, to the other gateway, which has the other end of the tunnel. It'll just ping back and forth, which does generate the interesting traffic, which will keep the tunnel up and alive. Now, the authentication header. This is done by sharing two keys between the peers, a shared key, secret key between the peers. This is important to understand, is that the authentication header is normally used between two gateways or two devices. So this is used when you don't care about somebody seeing the data. You need to make sure that it is not tampered with. So this data with authentication header goes over the clear. However, it's with using AH, you are guaranteeing the traffic does not get tampered with along the way. And in some cases, this is what you want. So what happens is it takes this one shared key, it runs the IP header and the raw data that it wants to send, which is the rest of the packet. It runs it through a one-way hash with the secret key, and then that generates a single hash. Now, it's important to note that when it takes stuff from the IP header, immutable headers like the time to live and stuff like that changes in transit when you normally send a packet is not included in this, because then it wouldn't make sense, because by the time they get it, when they rehash it to check, it will fail. So what happens is at the end, we have our IP header, we've got our raw data, and then we've got our hash. So it gets sent over as that. Then the peer will notice that there's a hash at the end, rehash everything with the secret key that was shared between the two, and then compare the hashes. If the hashes don't match, kicks it back. It knows it's been tampered with. If it hasn't been tampered with, then you're A-OK. Now, it's important to understand that with hashing, one bit changing or 1 byte. 1 bit, 1 byte, doesn't matter. Anything changes, you're going to have a different hash. Now, ESP. So ESP, or encapsulating security payload, this is going to be your most commonly used protocol with IPsec in an IPsec-based tunnel. Now, what this does, this provides encryption to the IP packet layer, which is the packet layer. It uses 56-bit DES by default for backwards compatibility, just so that any other devices, legacy devices, can handle that type, at least the base level of encryption, so something's there. Now, ESP uses quite a few different encryption protocols for its encryption. Now, you set this up when you bring up the tunnel. You can tell it what to do. Now, there's IKE, SHA-1, and 3DES. Now, IKE is something we're going to go over more detailed in this particular course. The others we're going to let be for homework for you guys to look up how they work with ESP. But know that it can use more than IKE. But in the enterprise world, you're going to find IKE is the most commonly used. So that's what we're going to go with for going forward for this particular course. Now, in an IPsec tunnel, there are two different modes. Now, the mode you want will determine what type of tunnel comes up. Now, we have a tunnel mode. This is where we want to connect one gateway to another, or one device to another, which I'm talking, when I say device, I'm talking about network devices, switches, routers, firewalls. We want to do this because this is most common for site to site, such as HQ to a remote office. This is what you're going to do. Both routers or both firewalls are going to connect to each other, and then they're going to generate a tunnel. This is going to be an IPsec IKE in tunnel mode. So this will be more apparent when we go over the actual implementation of this in another module. Just understand that the difference between the two modes, tunnel and transport. Now, tunnel mode acts like a proxy. So when you send traffic on the network, you send it from your host through the proxy, aka the gateway, that sends it to the other gateway, which is again the proxy for the remote host you're actually trying to touch. Now, transport mode is a little bit different. This works when you want to have a tunnel of secure connection between two peers. So if I wanted to talk with let's say my MacBook, I want to talk to somebody else on the other side of the office with a MacBook, I would build a tunnel between us two, and then we could have secure communication between us two. Or if I want to talk to a firewall and I need to do some administration, but I'm also on a public network, for whatever reason that needs to happen, you can create a tunnel between you and the firewall. The firewall in this case is a gateway, or it is a gateway by definition. However, because you're connecting to the firewall in the respects that you're only hitting the firewall, you're using the tunnel to reach the specific firewall, it's not considered in tunnel mode, it's considered in transport mode, because you're only going straight to that single device and it's being treated as a peer, not a gateway. So this is just kind of how IPsec works at a pretty high level. I want you to go ahead and look a little bit online to figure out a little bit more of how IPsec works. We're going to be going over the tunnels in the next few videos, so don't worry about that.